Many people wonder if it is really worth the economic and scientific effort involved in space exploration, having so many problems to solve on Earth. The answer is yes, because aside from simple curiosity, looking for an Earth 2.0 has the possibility of a second home, in case life on Earth is completely lost. However, as we explore and find possible new places, we realize that finding a new home is not the most complicated thing. The most difficult thing is the journey to that possible new home. For this and other reasons, our neighbor Mars is still the strongest candidate to establish a new civilization. So the most important questions when we talk about this are: is life on Mars possible? And was there ever life on Mars? That's why today we are going to see what science says about it. One of the conditions that scientists look for to determine the possibility of life on Mars is the existence of liquid water, and it seems that at some point in Mars history there were primitive oceans 4 billion years ago. Today's Mars is too cold to harbor liquid water on the surface. However, in an article published in the journal Science, advance suggests that for Mars to be warm enough to harbor liquid water on the surface, its atmosphere would probably have needed an immense amount of greenhouse gases, specifically carbon dioxide. Today, it is impossible to sample Mars' atmosphere from thousands of years ago to determine the carbon dioxide content. The researchers did not give up and decided to take samples from the Ries crater in southern Germany, which has a similar composition to Mars, and compared them with the samples taken by the Mars rover in the early 2020s, and concluded that both places had liquid water in the distant past. It is highly unlikely that ancient Mars had oxygen to support complex life forms. Some researchers suggest that microorganisms could have developed if the ancient Martian water would have had a neutral pH level and would have been highly alkaline. These conditions imply enough carbon dioxide in the atmosphere, perhaps thousands of times that present on Earth today. Since 2008, NASA maintains a catalogue of 57 meteorites that, according to the evidence, come from Mars. Of course, these meteorites are very variable to the scientific community, as they are the only physical samples from Mars that they can analyze. Of this group, there are 3 with peculiarities that some researchers believe may be indications of possible natural organic molecules or probable microscopic fossils. Meteorite ALH84001. This meteorite was found in Antarctica in 1984, weighing 1.93 kg, at some regular shapes that from some researchers may be fossilized microorganisms, similar to nanobios or nanobacteria. It also has some magnetite that on Earth is associated with certain microorganisms. Meteorite Nakhla fell in 1911 in the town of Nakhla, Alexandria, Egypt, but now obtained a small sample of this meteorite in March 1988, which was analyzed by optical microscopy and an electron microscope to determine its contents. The researchers observed homogeneous spherical particles, cellular structures and exopolymeric sequestrations were identified inside. NASA scientists concluded that at least 7% of the organic material could not be terrestrial contamination. In 2006, NASA requested another sample. In this new analysis, a high content of carbon was found in the form of ramifications. For some researchers, these traces are biological origin. For others, these curious forms do not suggest the possibility of biological origin. The Chagoti meteorite fell in India in August 1865. It is estimated that it was formed 165 million years ago and was exposed and transformed by liquid water for many years. Certain features of this meteorite suggest the presence of remnants of membranes or films of possible biological origin, but these interpretations vary. One of the gases that could indicate the presence of life on Mars is methane gas, and in 2003 NASA found a considerable amount of this gas in the atmosphere of Mars. The methane with Nika is still considered a mystery, because under the atmospheric conditions of Mars, this gas should disappear in a few years, so there must be a source that produces it. At first, it was thought to be a product of asteroids, but in this way only 0.8% of the total methane enters. Possible sources or geological evidence of the presence of life, but NASA still has no evidence to deny or affirm either one or the other. In 1999, NASA detected, thanks to the Mars Global Surveyor Orbital System, dark spots on the dunes of the ice cap of the South Pole of the Martian surface. The peculiarity of these spots is that 70% of them recur annually in the same place of the previous year. The spots on the dunes appear at the beginning of each spring and disappear at the beginning of each winter. A team of scientists from Budapest has suggested that these spots could be of biological origin and of extremophile character. It means of organisms with the ability to live in extreme conditions, conditions that we hardly know on Earth. However, NASA has proposed that the spots are the product of cold eruptions of geysers, which are powered not by geothermal energy as on Earth, but by solar energy. Scientists have explained that sunlight hits the interior of the polar ice and sublimates it to a maximum depth of 1 meter, creating a network of horizontal tunnels with carbon dioxide CO2 gas under pressure. Eventually, the gas escapes through a fissure and carries with it particles of basaltic sand to the surface. Radiation is a problem for life on Earth and elsewhere. In 2007, it was calculated that the supposed existence of life on Mars would be limited to a depth of 7.5 meters minimum due to the detrimental action of cosmic and solar radiation on the DNA and RNA molecules of any living organism. So the best chance of finding a history of life on Mars lies at the depths of the planet. Of course, the hope of finding life on Mars has also fallen victim to conspiracy theories. In 1976, the Viking probe was sent to the Martian surface, carrying a biological instrument. It means a container of 3 analysis kits just to find evidence of life. One of these kits was positive for metabolic activity, and what other proof of life could be obtained after this? Since the resulting tests with gas chromatography and mass spectrometer equipment did not detect natural organic molecules, and therefore the result could not be corroborated, so this experiment with inconclusive data has only fueled conspiracy theories. Some independent researchers continue to interpret this result as the evidence of metabolism and therefore of life. While on paper, a Dutch researcher proposed on the basis of this evidence that the Martian soil would probably develop activity between the bacterial and vegetation communities, resulting in a photosynthetic molecule which would not be chlorophyll but another that would reflect light in the reddish color band. In other words, he proposed that the surface of Mars would not have its reddish appearance because of ferrous oxide, but because of one or more organisms distributed over its entire surface. The Mars rover missions, besides giving us important data for the study of the Martian surface, have also given us incredible images, from sunset on the red planet to ambiguous shapes, which some conspiracy theorists have attributed to human creation or to a Martian civilization. Undoubtedly, the first of these was the famous Mars face, a feature of a photograph taken in the Cydonia region, which to some resembles a human face. The alleged face is approximately 3 km long and 1.5 km wide. For conspiracy theorists, such a structure cannot be anything other than the creation of a civilization. The image was taken in 1976 by the Viking space probe, so due to the low quality of the photograph and the angle of illumination, we can attribute this face to nothing more or nothing less than pareidolia. Even the area photographed recently and with better lighting does not look like a face at all. As you can see, although the red planet today seems somewhat hostile to harboring life, nevertheless, the efforts of scientists are focused on discovering any evidence that demonstrates the ability of Mars to harbor life, perhaps in part to understand what may happen to us in the future or to take advantage of this situation and make Mars our new home.